Mixture of expert models have become so popular that more and more companies are releasing their original models as MOE or mixture of experts. A mixture of expert model is a hierarchical model that combines multiple submodels or experts to specialize in different regions of input space with a gating network determining which expert to use for each input instance, enhancing model flexibility and performance. This model, which is Qwen 1.5 mixture of expert A to 7 billion, is a small mixture of expert model with only 2.7 billion activated parameters, yet it matches the performance of state-of-the-art 7 billion models like Mistral 7 billion and the original Qwen 1.57 billion. This model is a decoder only language model pre-trained on large amount of data. A decoder-only language model is a type of transformer architecture where the encoder is removed and the model generates sequences solely based on previously generated tokens, making it suitable for tasks like language generation and text completion without relying on input sequence. Compared to Qwen 1.57 billion, which contains 6.5 billion non-embedding parameters, this Qwen 1.5 MoE contains only 2 billion non-embedding parameters, which is approximately one third of Qwen 1.57 billion size. Notably, it achieves a 75% decrease in training expenses and accelerates inference speed by a factor of 1.74, and that offers substantial improvement in resource utilization without compromising performance. The researchers behind this Qwen 1.5 MoE have built this with a specially designed MoE architecture. Typically, as seen in methods like Mixtral, MoE layers within each transformer block employ 8 experts and utilize a top 2 gating strategy for routing purposes. This configuration is straightforward, but this new model has built upon it. So they have done a lot of experiments and they have modified this architecture with fine-grained experts, and they have also introduced a new concept called as initialization, which they call upcycling, and they have a new routing mechanism with shared and routing experts. Also, they have taken an inspiration from DeepSeek mixture of expert and DBRX by Databricks, and they have improved this model a lot. Just a note on initialization feature, then is initialization stage of the model is critical. Their initial experiments suggest that training a MOE model from scratch may prove inefficient and challenging to elevate it to anticipated peak performance. That is why they have started by repurposing or upcycling their existing Qwen 1.8 billion, transforming it into Qwen 1.5 mixture of expert 7 billion. So introducing randomness during initialization significantly expedites convergence and results in superior overall performance throughout the pre-training process. I will drop the link to this model card and you can read further about it. But for now, let's get started and see how we can locally install this Coin 1.5 model. Let me go to my local system where I am running my Ubuntu. I have one GPU card with 20 GB of VRAM and my memory is 32 GB. Let me clear my screen. The first step we need to do is to clone the transformer repo, because in the existing repo which is available through pip, this new feature is not available, especially the Qwen mixture expert implementation, so we need to clone it. So let me clone the transformer library. Let's wait for it. It is quite big, so make sure you have plenty of space on your system. Almost there, and then we will cd to this directory once the deltas are done. And now let's install from the source. So let's wait for it to finish. This takes a bit of a time. And this is done. Okay, and you can ignore these warnings in red. These are from my other project. So let's clear the screen, launch our Python interpreter, and now let's first import that auto model for causal element tokenizer so that we will be able to download our model. And then we are going to specify our model, which is our Qwen chat model. And I'm going to use the quantized version. Okay, so we would need to install this package. Let me install it. So I have installed the optimum, but it has also installed transformers. And so we would need to reinstall it with just pip install e. So let me reinstall that. Hopefully it won't break it. Let's wait for it to finish. Transformer is done again. So we can do pip show optimum. That is good. And pip show transformer just to make sure we are on the right versions. Yep. So the version is right here as you can see. And this is optimum version. Okay, let's clear the screen. Let's launch our Python interpreter again and let's import the libraries. So both the auto model for causal and tokenizer are done. Let's run this. Okay, so let me install AutoGPT-Q again. So I think I have the older version, so I'm just doing it with upgrade option. Let's wait. Yep, it is doing it. Hopefully it won't uninstall my other one. That is good. Let's clear the screen, go to Python, and then import the libraries again and do our model. Libraries are done, and now let me load our model. And this time, thankfully, it has started loading it. It says CUDA extension not installed, but that is fine. Let's wait for it. And the size is quite big. So if we go back to our model card, if you go to files, then you can see the size is around 4, so 12, 16, 20, 24, 28. 28 gig of size you should have on your system. I have that much space, but I'm not sure if my GPU would be able to support that much, but let's see. Let's wait for all of these to download. It depends upon your download speed. So I will wait for all the shards to load and then we will go from there. Two shards are done and the last one is in progress. So let's wait for this one to finish. So it has downloaded the shards and also have loaded the checkpoints. Let's get our tokenizer. That shouldn't take too long. That is done and you can ignore these warnings for now. Let's give it a prompt and try it out. Installation of model is done. Let's see the inference. So I'm just giving it this short prompt and then let's put it in our prompt template. So it is in the same format of system and user. That is done. Let's feed it to tokenizer to convert the prompt into tokens. That is done. Let's send it to our model. So this is the input we prepared. Let's generate the model output. So we are sending it to model and then let's get the once this is done, because this is where model is generating the output, going through the prompt and things are passing through its layers. Let's wait for it to come back. The model has generated it. Let's get the generated IDs. That is done. Let's get the response. And now let's print the response here. There you go. So it has given us what exactly a large language model is in a very, very succinct way. Very cool. Okay, let's ask it another question in a prompt. So I'll just ask it, create a short story where characters from different fictional universe unexpectedly find themselves transported to a shared dimension and they must collaborate to overcome a common threat each contributing their unique abilities to the group dynamic. So let's first create the prompt template and then create the model input. I'm just going to paste everything in one go, and then let's get the generated IDs, and then let's wait for the model to print to get the response, and then we will print it out. Okay, model took a long time, but it has come back. Let's print it out. There you go. So I'll just scroll up. You can see that the story has been printed, and it is saying that once upon a time in a far off galaxy, the heroes of different worlds found themselves transported to a strange realm. So you can see that first thing they notice suddenly aloud. So there are characters. There is a Hermione's character with a shield, and as the battle raged on, blah blah blah. Because I have restricted the tokens to 512, as you can see here. Sorry. So that is why it has cut off the generation, which is fine. Okay, let's ask it a complex coding question to see if it is able to do some sort of coding stuff or not. Let me put the prompt here first, and then we will see. I'll just make it bit like this. Okay, so the prompt here is that design an algorithm to efficiently find the longest palindromic substring within a given string, considering both time and space complexity constraints. So it is a bit complex. So let's see if it is able to do it. Let me send the prompts, model inputs. Let's get the model to generate the output here. And let's wait for the model to come back. Model has come back. Let's print out the response. There you go. Wow, pretty cool. Let's see. This is the algorithm, and it has also given us the whole synopsis of it, that what it has done, that initialize this, and then it has defined that algorithm. Seems like C++, but really good. There you go. Looks really good. And then it is returning it. And then it is also telling us about the complexity of this, the time complexity of this algo, because we iterate over each character. Amazing stuff. Amazing. So that's it, guys. There are a lot of things which are great about this model, and I believe that as we speak for today, this is the best mixture of expert model to date. Even I believe that this is better than Mistral, which is, of course, a pioneer in this, but I think this has really taken it to next level. Very impressed by it. Let me know your thoughts. If you like the content, then please consider subscribing to the channel, and if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.